Biodiesel is considered a Class 2 combustible liquid. Waste vegetable oil is considered a Class 3 combustible liquid. Above-ground tanks must be double-walled or have a secondary containment system equivalent to the tank capacity. Underground tanks must be installed to the manufacturer's specifications and local building codes. Tanks must be equipped with overfill protection devices. Dispensing equipment must comply with the code. Biodiesel and waste vegetable oil are not considered hazardous materials, but they are combustible liquids and should be handled accordingly. Adequate ventilation and electrical grounding are required in storage areas. Smoking and open flames are prohibited near storage tanks. The National Electrical Code, NFPA 70, addresses electrical wiring in environments where biodiesel or waste vegetable oil are stored or handled. A Class 1, Division 2, or Code D2 classification is required in areas within 25 feet of bulk storage tanks or dispensing equipment for biodiesel or waste vegetable oil. When installing electrical wiring in a biodiesel or waste vegetable oil environment, it's crucial to adhere to specific guidelines to ensure safety and prevent explosions. Firstly, use explosion-proof or intrinsically safe electrical equipment. This type of equipment is designed to contain any potential sparks or explosions within its enclosure, preventing them from igniting flammable vapors in the surrounding atmosphere. Secondly, conduits must be sealed and grounded. Sealing the conduits prevents flammable vapors from entering the electrical system, while grounding ensures that any static electricity built-up is safely discharged. Thirdly, lighting fixtures must be rated for Code D2 These fixtures are designed to operate safely in environments where flammable vapors may be present. Fourthly, wiring must be protected from physical damage. This can be achieved by using appropriate conduit and ensuring that wiring is properly supported and protected from abrasion or impact. All electrical equipment must be properly grounded to prevent static discharge. Grounding rods must be installed in accordance with local building codes. Install smoke detectors and fire extinguishers in storage areas. Train personnel on hazardous material handling and emergency procedures. Regularly inspect electrical equipment and inspect for leaks or other hazards. The NFPA 30 Flammable and Combustible Liquids Code provides detailed requirements for the safe storage and handling of flammable and combustible liquids, including biodiesel and waste vegetable oil. Understanding these requirements is essential for preventing fires and explosions in these environments. Firstly, proper tank construction is critical. Above-ground tanks must be double-walled or have a secondary containment system equivalent to the tank capacity. This helps to prevent leaks and spills, which can create hazardous conditions. Underground tanks must be installed to the manufacturer's specifications and local building codes. This ensures that the tanks are properly protected from corrosion and physical damage. Secondly, overfill protection is essential. Tanks must be equipped with overfill protection devices, such as automatic shut-off valves or high-level alarms. This prevents spills that can occur when tanks are overfilled. Thirdly, dispensing equipment must comply with the code. This includes requirements for nozzles, hoses, and pumps to prevent leaks and spills during dispensing operations. While biodiesel and waste vegetable oil are not considered hazardous materials, they are combustible liquids and should be handled accordingly. This means taking precautions to prevent ignition and spills. Firstly, adequate ventilation is required in storage areas. This helps to prevent the accumulation of flammable vapors. Secondly, electrical grounding is essential. This prevents static discharge, which can ignite flammable vapors. Thirdly, smoking and open flames are prohibited near storage tanks. This reduces the risk of ignition. When working with biodiesel and waste vegetable oil, it's important to follow these handling requirements to ensure safety and prevent accidents. By adhering to NFPA 30 and NFPA 70, you can create a safe environment for storing and handling these combustible liquids. Remember to consult the specific codes and local regulations for detailed requirements and guidance. Safety should always be the top priority when dealing with flammable and combustible materials. The Class 1, Division 2 designation means that the area is one in which flammable gases, vapors, or liquids may be present under abnormal operating conditions. This could be due to accidental spills, leaks, or equipment malfunctions. Because of this potential hazard, special precautions must be taken when installing electrical equipment in these areas. Explosion-proof equipment is designed to contain any internal explosion, preventing it from igniting the surrounding atmosphere. Intrinsically safe equipment, on the other hand, is designed to operate at such low energy levels that it cannot produce a spark hot enough to ignite flammable vapors. Both types of equipment are suitable for use in Cone D2 areas, but it's important to choose the right type for the specific application. Conduits are the metal or plastic pipes that protect electrical wiring. In Cone D2 areas, conduits must be sealed to prevent flammable vapors from entering the electrical system. This is typically done by using a sealing compound at the conduit entry points. Grounding is the process of connecting electrical equipment to the earth, providing a path for stray electrical currents to flow. In Cone D2 areas, grounding is essential to prevent static discharge, which can ignite flammable vapors. Lighting fixtures used in Cone D2 areas must be rated for the specific hazardous location. These fixtures are designed to prevent sparks or hot surfaces from igniting flammable vapors. Wiring in Cone D2 areas must be protected from physical damage to prevent shorts or other electrical hazards. This can be done by using appropriate conduits and ensuring that wiring is properly supported and protected from abrasion or impact. Grounding rods are metal rods that are driven into the earth to provide a grounding point for electrical equipment. The number and placement of grounding rods must comply with local building codes. Smoke detectors and fire extinguishers are essential safety equipment in any storage area, especially those containing flammable or combustible liquids. Smoke detectors provide early warning of a fire, while fire extinguishers can be used to put out small fires before they spread. Training personnel on hazardous material handling and emergency procedures is crucial for preventing accidents and responding effectively in the event of a fire or spill. Training should cover topics such as proper storage procedures, spill response, and fire extinguisher use. Regular inspections of electrical equipment can help to identify potential hazards, such as loose connections, damaged wiring, or corroded components. Inspections for leaks or other hazards can help to prevent spills and fires. Any identified hazards should be addressed promptly to prevent accidents. In summary, wiring in a biodiesel or waste vegetable oil environment requires careful attention to detail and adherence to specific safety standards. By following these guidelines, you can minimize the risk of fire or explosion and create a safe working environment. Remember to consult with a qualified electrician or engineer to ensure that your electrical installations comply with all applicable codes and regulations. The flash point of a liquid is the lowest temperature at which it can form an ignitable mixture in the air near the surface of the liquid. Combustible liquids have flash points at or above 100 degrees Fahrenheit, while flammable liquids have flash points below 100 degrees Fahrenheit. Biodiesel typically has a flash point above 130 degrees Celsius, which is approximately 266 degrees Fahrenheit, classifying it as a combustible liquid. Waste vegetable oil also has a relatively high flash point, typically above 200 degrees Celsius, which is approximately 392 degrees Fahrenheit, also classifying it as a combustible liquid. The higher flash points of biodiesel and waste vegetable oil compared to some flammable liquids like gasoline make them somewhat less prone to ignition under normal conditions. However, it's still crucial to handle them with care and follow all safety precautions to prevent fires or explosions. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in various locations, including those involving hazardous materials. Article 500 and subsequent articles in the NEC cover the requirements for electrical equipment and wiring in hazardous locations, including Class 1, Division 2 areas. These articles specify the types of equipment that are permitted in each class and division, as well as the wiring methods and grounding requirements that must be followed. It's essential to consult the NEC and any applicable local codes to ensure that electrical installations in biodiesel and waste vegetable oil storage areas comply with all requirements. Proper ventilation is crucial in storage areas to prevent the accumulation of flammable vapors. Natural ventilation can be achieved through the use of windows, doors, or other openings. Mechanical ventilation systems can also be used to provide a continuous flow of fresh air into the storage area. The ventilation system should be designed to effectively remove any flammable vapors that may be released from the biodiesel or waste vegetable oil. Grounding and bonding are essential for preventing static discharge, which can ignite flammable vapors. Grounding involves connecting electrical equipment to the earth, while bonding involves connecting different metal parts of the electrical system together. This creates a low-resistance path for stray electrical currents to flow, preventing the buildup of static electricity. All electrical equipment in a biodiesel or waste vegetable oil storage area should be properly grounded and bonded in accordance with the NEC. Spill containment is an important aspect of safety in storage areas. Spill containment systems are designed to prevent spills from spreading and contaminating the surrounding environment. These systems can include berms, dikes, or other barriers that contain any spilled liquid. Spill kits should also be readily available in storage areas to allow for quick and effective cleanup of spills. Emergency shutdown systems can be used to quickly shut down equipment in the event of a fire or spill. These systems can include emergency shut-off switches for pumps, valves, and other equipment. Emergency shutdown systems should be clearly labeled and easily accessible in storage areas. Fire suppression systems can be used to automatically extinguish fires in storage areas. These systems can include sprinklers, foam systems, or other types of fire suppression equipment. Fire suppression systems should be designed to effectively extinguish fires involving biodiesel or waste vegetable oil. Personal protective equipment, or PPE, is essential for protecting workers from hazards in storage areas. PPE can include items such as gloves, eye protection, and respirators. Workers should be trained on the proper use of PPE and should always wear appropriate PPE when handling biodiesel or waste vegetable oil. Safety signage is important for communicating hazards and safety precautions to workers and visitors in storage areas. Safety signs should be clearly visible and should use appropriate symbols and wording to convey the message. Signs should be used to warn of hazards such as flammable liquids, electrical hazards, and spill hazards. Regular inspections and maintenance are essential for ensuring the continued safety of storage areas. Inspections should be conducted regularly to identify any potential hazards or problems. Maintenance should be performed as needed to keep equipment in good working order and to address any identified problems. In addition to the NFPA and NEC standards, there may be other applicable codes and regulations that must be followed when storing and handling biodiesel and waste vegetable oil. These codes and regulations may vary depending on the location and the specific application. It's important to consult with local authorities and experts to ensure that all applicable requirements are met. The proper handling and storage of biodiesel and waste vegetable oil are essential for protecting the environment and preventing accidents. By following the guidelines and best practices outlined in this narration, you can minimize the risk of fire, explosion, and environmental contamination. Remember to prioritize safety in all aspects of your operations and to consult with qualified professionals when needed. The specific requirements for electrical wiring in Class 1, Division 2 locations are detailed in Article 504 of the National Electrical Code. This article covers the requirements for intrinsically safe systems, which are often used in these types of hazardous locations. Intrinsically safe systems are designed to operate at such low energy levels that they cannot produce a spark hot enough to ignite flammable vapors. The installation of intrinsically safe systems requires careful attention to detail and adherence to specific wiring methods and grounding requirements. Article 505 of the National Electrical Code covers the requirements for zone classifications, which are an alternative to the division classifications for hazardous locations. Zone classifications are based on the frequency and duration of the presence of flammable gases, vapors, or liquids. Zone 2 is similar to Division 2. in that it is a location where flammable materials are not normally present but may be present under abnormal operating conditions. The requirements for electrical wiring in Zone 2 locations are similar to those for Division 2 locations. The selection of appropriate electrical equipment for hazardous locations requires careful consideration of the specific conditions at the site. Factors to consider include the type of flammable material present, the frequency and duration of its presence, and the temperature range of the environment. The equipment must be rated for the specific hazardous location and must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. The use of flexible metal conduit in hazardous locations is subject to certain restrictions. Flexible metal conduit is generally permitted for short runs where flexibility is needed, but it must be properly grounded and must not be used as the sole grounding conductor. The length of the flexible metal conduit run is typically limited to a maximum of 6 feet. The use of non-metallic conduit in hazardous locations is generally prohibited unless it is specifically approved for use in such locations. Non-metallic conduit is not as strong or durable as metallic conduit and is more susceptible to damage from chemicals and physical abuse. The inspection and testing of electrical equipment at hazardous locations is essential for ensuring its continued safety and reliability. Inspections should be conducted regularly to identify any potential problems or defects. Testing should be performed to verify that the equipment is functioning properly and that it meets all applicable safety standards. Records of all inspections and tests should be maintained for future reference. The training of personnel who work in hazardous locations is essential for preventing accidents and ensuring safe operations. Training should cover topics such as the hazards of flammable materials, the proper use of electrical equipment, and emergency procedures. Personnel should be trained to recognize potential hazards and to take appropriate actions to prevent accidents. The use of cell phones and other electronic devices in hazardous locations is generally prohibited unless the devices are specifically approved for use in such locations. Electronic devices can generate sparks that could ignite flammable vapors. It's important to follow all safety regulations regarding the use of electronic devices in hazardous locations. The storage of flammable liquids in containers requires careful attention to detail. Containers must be properly labeled and must be stored in a well-ventilated area away from sources of ignition. The containers must be compatible with the flammable liquid being stored and must be protected from physical damage. The transfer of flammable liquids from one container to another requires special precautions to prevent spills and static discharge. The containers must be properly grounded and bonded to prevent static buildup. The transfer should be performed in a well-ventilated area away from sources of ignition. The disposal of flammable liquids must be done in accordance with all applicable regulations. Flammable liquids should not be poured down the drain or disposed of in the trash. They should be collected and disposed of by a qualified waste disposal company. The cleanup of flammable liquid spills requires prompt and effective action to prevent fires and environmental contamination. The spill should be contained and the area should be ventilated. Absorbent material should be used to soak up the spilled liquid. The used absorbent material should be disposed of properly. The investigation of accidents involving flammable liquids is essential for identifying the causes and preventing future accidents. The investigation should be conducted by qualified personnel and should include a review of the equipment, procedures, and training involved. The findings of the investigation should be used to improve safety procedures and prevent future accidents.